So let's talk about what this is first, and we'll go through 3 definitions before we actually find the area of a regular polygon. When I say a regular polygon, what does that mean if it's regular? What do you think? Very good. Okay, the sides are all equal to each other, and the angles are all equal to each other. Okay, that would be a regular polygon. Please stop the talking. Just listen to me. Of course you're taking notes on it. What kind of question is that? I'm teaching Makai. No. Absolutely not. Absolutely not. Are you kidding me? What would go through your head to think that that's fine, that I'm fine with that? Can we start again? No, I'm waiting for everybody to be quiet. So what we're going to do is we're taking a regular polygon. Okay, it could be a triangle, could be a rectangle, could be a pentagon, whatever. Okay, we're going to find the area of it. We already know how to find the area of a couple things. We already know how to find the area of a rectangle. We already know how to find the area of a triangle. But what if I asked you to find the area of a 5-sided figure, a pentagon, right? We haven't really learned how to do that yet, except for today. Today we're going to learn how to find not just a pentagon, but any regular polygon. There's a simple little formula, but we got to talk about 3 words before we talk about the formula. All right? The first word is the radius. All right? So the radius, I'll tell you what I'm going to do. I was going to have you write down the definitions, but I'll read it to you, and let's make this a pentagon, since I've been talking about pentagon. And let's see, what do I want to do? I want to do this. All right, so there's a pentagon. So we're going to talk about 3 words. One is radius. The other, I'll just write them all down, then I'll show you on the picture. Then the central angle. And then a word that you probably never heard before, but it's called an apothem. A-P-O-T-H-E-M. That's a brand new word. All right, so that's something that we need to talk about as well. You've probably talked about radius before in other classes before you ever came in here in geometry. When did you talk about a radius, do you think? Circles, that's right. So if I had a circle, okay, which we're not talking about today, but I think the next lesson, I think we are talking about circles. Let me put a little dot right there. So I'm just showing you the similarity between what you already know about a circle, and then we're going to relate it to this. All right. So what would you call that dot right in the middle? Now, the dot in the middle is not the radius. It's not the diameter. It's the center of the circle. Okay, it's the center of the circle. This little line right here, the distance from the center to any point on the circle right here, we call that the radius. All right? So that shouldn't be brand new to you. Okay, you probably learned that. Shh. Quit speaking out, please. Please, quit speaking out. If you have a question, raise your hand and I'll call on you. But let me finish talking first. Okay, and don't just yell things out. Put your hand down. I'm not finished talking. So we have a center, we have a radius. We also have a center of a regular polygon. This doesn't work with just any old polygon. There's no center really to just any normal polygon that don't have all the sides and angles equal to each other. But when all the sides and angles equal to each other, then you do have a place. And this program right here, if I just click on it, actually shows me all these dots and stuff, but it actually shows me where the center would be located. So that's kind of nice that this program has that. So I'll just put a dot right there. So we would call that point right there the center of this polygon, or in this case, a pentagon. Okay, that's the center.
With applying students, please come to the office. Pam Hayden, Ben Fabian, Megan Katanabama, Hannah Deedle. Thank you.
If I draw a line segment from the center to one of the vertices. Remember the word vertex? Yeah, we've used that all year long. Okay, this is one of the vertices. That's just a plural of vertex. So to this vertex right there, we would consider this, what do you think? It's kind of like the circle, but it's not really a circle, but it's kind of like what? What do you think I'd call that line right there? I'd call that the radius. That's right. Okay, so from the center of the polygon to a vertex would be called the radius. Leona. Radii. Radii. So there's the center. There's a vertex. Now watch. If I took the radius of a circle and I said from the center to any point on the circle, what if I made it like from here to here? What would be true about this radius compared to this radius right here? They're the same, okay? The radius on a circle are always the same length. Everybody with me on that? So from the center to anywhere on the circle at all would be the same length. It's kind of the way here, kind of, not exactly. But if I go from the center of the polygon to any of the vertices, to any vertex, all right? So if I wanted to go to that vertex, if I wanted to go to this one, all right, we'll just put them all in there. If I wanted to go to this one and one more vertex, if I wanted to go to that one right there. Some of them don't hit exactly, but you get the idea, okay? If I go from the center to any of these vertices right here, tell me something about those lines that I just drew. What do you think is true about all of them? They're all equal to each other, okay? They're all exactly the same, all right? So it's kind of like a radius, isn't it? Okay, but now if I took a, let's do this in another color. Let's not do that yet. I'm going to do something different before I get to it. So we know what a radius is, okay? So we've talked about that. Now what's the next thing? A central angle, okay? It's the central angle. So it's the angle formed at the what? The center, all right? And what angle is that? Well, this would be right there. That would be a central angle. Well, what would this angle right here be? A central angle. What about this one? That's also a central angle, okay? So the angle from the center, okay, formed by two radii. There's your plural for radius. Radii, R-A-D-I-I. That's the plural of radius, okay? So that angle right there, formed between two radii, that's called the what? Central angle, okay? Everybody got that? What do you think might be true about all the central angles? They're all equal to each other. This one, this one, this one, this one. All of those yellow arcs right there, they're all exactly the same. They're all equal to each other. So that comes in helpful sometimes. All right? And you know these lengths right here, like this length right here and this length right here, they're the same as well. All of them, right? This one, and this one. They're all the same length. Everybody good so far? All right, so we know what the central angle is. We know what the radius is. We know that the radius are all equal to each other. We know all the central angles right there are all equal to each other. So that's something important to know. Now, there's another thing. That's the apothem. This is the word you've never heard before, probably. My guess is. Has anybody heard that word? I really doubt it. Okay, so you've probably never heard that word before, but here's what it is. It's not that hard. It's from the center, but it's not to the vertex. It's to any of the opposite sides, but not just anywhere to the opposite. It's not just from there to there, not from there to there. It's not just from there to there. Where do you think it is? It's perpendicular. Very good. It's perpendicular to one of the opposite sides. I could have drawn the apothem to here if I wanted to. I could have drawn it to here, or to here. I decided just to draw it straight down. And it's got to be perpendicular. So if it's perpendicular, what must be true about this? Must be a 90-degree angle, right angle. Okay? So that yellow one right there is the what? The apothem. Okay? Okay. Well, it would have to be at 90 degrees. Okay? There's a bunch of apothems. How many apothems would there be? 5 of them. There's one here, one here, one here, one here, one here. There's 5 of them. Okay? If I wanted to, I could draw the apothem here, but it would have to be what? Not just anywhere on this side. It would it will be in the middle, but it's got to be perpendicular. Everybody see this? It's perpendicular. Now, John brought something up. He didn't realize that he did, but he brought something up that's very true. That this apothem, it hits at a perpendicularly, all right? It hits at a right angle, but it also hits at a special place on that side right there. Where do you think it hits? In the middle. That's right. Okay, so what we say is the perpendicular. We say it's the perpendicular bisector. So that means that this little bit right here and this little bit right here would be equal to each other. So there's a lot of things you know about this on a regular polygon now. And a lot of this stuff will come into play. There's going to be a way, hope we're listening, this angle right here, and we can figure out what that angle is. Maybe here in a second we'll actually do that, okay? We're going to be able to figure out what that actual angle is, all right? It's really not that difficult if you think about it. And we're going to be able to figure out this little angle right here. You see that angle right there? So if we know this one right here, what do you think? What do you think that central angle, what do you think that perpendicular line does to that central angle right here? It bisects, exactly right. So if I knew what this big angle is right here, then all I got to do is take half of it and I got this angle here. All right? So there's a lot of stuff that we actually know about this and we can figure out. Let's do this. This is a pentagon. It's 5 sides. All right? Let's figure out what this angle, I'll tell you what, I keep saying this angle and I'm making like all kinds of arcs and all that kind of stuff. Oops. Let's just see if I can click it. There we go. Let's make this just a different color just so it stands out a little bit. So watch. Makai, I'm tired of you being in here, so you're going to leave. There's a seat right out there by the hallway. You're not paying attention anyway, so it doesn't really, it's not going to stop your education because you're not paying attention anyway. So just walk out the door, sit in that seat, and then we'll see you at the end of class. Okay? Maybe somebody didn't have a talk with you on what kind of school we are, okay? But maybe we'll have that talk after class, you and me. All right, so here we go. So there's that angle right there. We're going to actually figure out what that angle is. All right, let's do it right now. So how would I see that pink angle right there? How in the world would I figure out what that pink angle is? Well, first of all, I find the whole central angle, okay? Now, remember what I did earlier. I erased them. But remember I said, let's do it in a different color. Let's go back to yellow again. Okay, remember I said that's the central angle? So is that, so is that, so is that, and so is that. Now, they're all the same. So what if I started here and went all the way around? It kind of looks like a what? A circle. How many degrees in a circle? 360 degrees, right? So how could I find that central angle then? Divided by what? Divided by 360? And I get a 1? Is that what it would be? Why by 4? Are there 4 angles? Right, there's 5 angles. Look, there's 5 angles. And they all, watch, if you connected them all, it would be 360 degrees. Would you agree? Because if you started here and you went all the way around back to where you started, that would be 360 degrees. So how many angles make up that 360 degrees? 5 of them. So what would you do with that 360? Divided by 5. Somebody do that for me. What's 360 divided by 5? Nobody's got the calculator on them? I should be able to do this on in my head, but I'm going to put it in a calculator. So 360 divided by 5, 72. All right, so that would be 72 degrees. Now, let's go back. Oops. Let's go back to that color. Now, the whole central angle, the central angle right here is 72 degrees. But I want to find just the angle in this right triangle right here, this pink one right here. What's that? That's right, is half of it. Because remember, this perpendicular bisects it. Remember that? So what's 72 divided by 2? It is 36. I can do that one in my head. All right. So that's 36. So this angle right here is 36 degrees. Now, let's do some more. All right. Now, I'm not like doing an example just yet. I will here in a minute. All right. And we're not going to do a pentagon. We'll do an octagon. But I just want you to start. I want you to get thinking on how we're going to solve some stuff. All right. So if I know this is if I know that's I know it's kind of small, but that's 36 degrees, okay? If that's 36 degrees, how would I find this angle right here? What is it? Yeah, this angle right here. How would I find that angle right there? Yeah.
No, she doesn't. She doesn't have a necklace.
It's just 90 minus 36. Okay, which would be what? 54 degrees. So this angle right here would be 54 degrees. All right? So that can be very helpful to us sometimes. All right? Because they might ask for it. They might ask for that angle or something like that. Okay? Now, we may use that in the next problem. We may not. But it can be really, really important from time to time. Yes, sir. Because it's a right triangle. 180 minus 90 is 90. So that's what I did right there. These two angles always add up to 90 on a right triangle. Okay? All right? All right, I think that's enough. Let's do a real example now. Okay? Let's go back to using the whites. And now I'm going to make an octagon. How many sides does an octagon have? There we go. All right. So this is really no different. It's stressing me out. Why? You've understood everything we've talked about. It's stressing me out that I can't grab the dumb octagon and move it over here. All right, just make it a little bit bigger so we can see it. All right, let's do this. Let's just put a couple things in here. There's the center right there. So I'll just write the center. No. So let's see what they're going to do. They name this angle R. This is angle Q. And what is that? It's point P. All right. So what they're going to ask two things. First thing they're going to ask is to find the central angle. Find the central angle. All right, so here's your picture. So we're going to have to draw a little bit, aren't we? So let's draw. We've labeled these, so let's just label, or let's just mark this. So from P to Q, what would that be? What did I just draw right there? I drew the radius. Very good. And then I'm going to draw another radius from P to R, because I'm not going to be able to get a central angle unless I have a couple radii. Okay? So there it is. Now, I didn't do the one that's like up and down. It's the one. This one's kind of crooked, but that's okay. We can still do that. We can do this with any of these two radii in here. Okay. Let's see. What else do we want to do? Oh, we want to find the central angle. So let's find this angle right here, angle P, or angle QPR, whatever you want to call it. We'll just call it angle P. It is the central angle. How do we find that central angle right there? Divide. Divide what by what?
It's 8.
It's not 360, it's 8?
You know that it's 8 into 360.
8 into 360. Okay, that'll work for me. So it's 360 degrees altogether. Remember, the whole thing, right, from here all the way to here would be 360. I don't have to draw all those other radii, do I? All right, but you know you would have how many angles if I drew a radius to every vertex? I would have 8 of them, right? So if I just want to find one of them, they all add up to 360, right? And so if I wanted to find just one of the angles, then what would I do? I take that 360 and divide it evenly by 8. And that actually comes out to 45 degrees. All right, so that's the central angle. That's part A. That's easy, isn't it? Yeah. Yeah, just take a whole bunch of things, divide it by how many angles you have or how many sides. Because you know you're going to have just as many central angles as you have vertices, or how many sides you have, right? If it's 8 sides, how many central angles are you going to have? You're going to have 8 central angles, okay? Remember, they all add up. They kind of make a circle, right? If I started here, look, if I started here and I went all the way back to the beginning right there, kind of makes a circle. Would you agree?
Yeah.
Now, you don't see all those angles in there, but yeah, they would all add up, right? They would all add up to 360 degrees. Divided by 8, because there's 8 of them, It's 45 degrees apiece, okay? Here's another word that I did not talk about, and I should have, but we'll talk about it right here in this example. The base angle. Let's talk about a base angle. We actually found it. We actually found it in the other one. So which one of the angles that we talked about? We didn't say it was the base angle, but we actually did find it. Which one do you think would be the base angle out of all this stuff that we drew right here? The 54, that's right. This angle right here, everybody see it? This angle right here would be called the base angle. Remember, this is the central angle, this whole big angle right here. But the angle that's made by the what? The radius and one of the sides, that would be called the base angle. All right, so let's come over here. So which one would be the base angle in this situation? Well, which one? Which one of the, name the letter. It would be angle Q, right? So I'll put 2 arcs right there, okay? Since both of these radii are equal to each other, angle Q and angle R are exactly the same. It's not. We don't have a 90 degree. We don't know that's 90 degrees, okay? We do know that that's 45 degrees right there, okay? But now watch. Listen to what I just said. What do we want to find? We want to find the base angle. That's what part B of this question says. Find the base angle. So we want to find angle Q. So think a little bit. Don't make me do all the work. Think a little bit. Trent?
So you subtract 45 from 180.
Okay. Why do you divide it by 2?
Because Q and R.
Right. Q and R are exactly the same. All right. How do I know they're the same? Because this is a radius and this is a radius. Okay. So this is a isosceles triangle. Remember, we said if you have a polygon and 2 of the sides are equal to each other, or let's say a triangle. If you have a triangle and 2 of the sides are equal to each other, the angles that are opposite those sides are also going to be equal to each other. So if I'm trying to find Q, R would be the exact same thing. Agreed? So listen to what Trent said. We got to find R and Q, right? So it's not necessarily 45, 45, 90, okay? But this is 45. So if I take 180 minus 45, what does that give us? 135, okay? But does that mean angle Q is 135 degrees? No. But they add up to be, right? These 2 angles add up to be 135 degrees. So how do I find, if they're both the same, how do I find out what each of them are? I just divide it by 2, okay? So it's like if I gave you $135 and I said you got to split it between 2 of you, what would you do? You divide it by 2. It's what we have here. These add up, these add up to 135. These add up to 135. And so if they're both exactly the same, which they are, we just split them in half. So you just take this, I'll just do it over here. Take the 135 and you divide it by 2, and that is 67.5 or 67.5. So this angle Q is 67.5 degrees, and the angle R is the exact same thing, 67.5 degrees. All right? Now, we still haven't even talked about finding the area of this thing yet, have we? All right? They're leading you up to it, all right? They're working their way to it. So they do have a formula. We already kind of figured out the formula. What would the formula be to find the central angle? If we wanted to make up a formula on our own, and we wanted to find the formula to find the central angle of a regular polygon, what have we been doing to find that angle right there? We always do what? Take 360 divided by how many what? How many angles or how many sides? They use the letter N to represent how many sides this thing has. N for number, right? Number of sides. So what would our formula be? 360 divided by what? N. And that's it. There's your formula for finding the central angle. And we kind of knew that already, didn't we? We kind of figured out how to do that already when we were up here. All right? But they make a nice little formula for it. It's a theorem and everything else, and it's right in there. So now, I think we're ready to guess what? Find the what?
Area.
Find the area of a regular polygon. I'm going to go back to making a pentagon because that's what the example in the book has. So that's 5 sides. So there we go. Let's make it a little bit bigger. right there. And then we'll push it over like this. Okay, so what we're going to do is we're going to find the area of this. Let me see. Did I make that a... Hold up. Let me see something. Yeah. All right. So this is the only thing that they tell you. The only thing that they tell you is the length of one of the sides. Okay, and what we have to do is find the area of this pentagon. Okay? Well, we need a formula. We don't have a formula yet, so here's the formula. Now you know one of the words. All right, so we can write it down. So here it is. It's 1/2 A. What do you think the A stands for? No, it's the word that you never heard until today. The apothem. A stands for the apothem. Times P, which, what do you think P stands for? It could stand for polygon, but it doesn't. It stands for the perimeter. Okay, it's the perimeter of the thing. Okay? Okay. So watch. Really, you only need to find what? 2 things, don't you? In order to find the area of this. Would you agree? You got to find the apothem, which I have no idea how to do that right now, but maybe we will in a few minutes. But what's the one thing that we absolutely can find right now? The perimeter. We should absolutely be able to find the perimeter of this. Okay. So let's do it first. So how would I find the perimeter of this? 10 times 5. That's right. There's 5 sides. There's 5 sides, right? So this would be 10. This would be 10, 10, 10, right? And so it's just 5 times 10, which is what? 50. This is not the problem that that's the example. I wrote, stop. Let's just do this. Sorry about that. I made, stop. It doesn't matter. Aren't you talking when I've told you not to talk about 10 times today? Yeah, you made that way too easy for me. All right, let's not use the pentagon just because. The only reason is because that's not the one in the book. All right, that's not the example they use in the book. All right, so let's change this back to an octagon like we were just doing earlier. Okay, so we actually know some of these numbers already since we know it's an octagon. So here's what we're going to do. We're going to find the area. First of all, we know the perimeter now. Now, it's an octagon, so how many sides? It's not 5 now, it's what? It's 8. So what's the perimeter of it? It's 8, okay? That's just the perimeter. So now all we have to find is one more thing. I plug it into this, and it should be pretty easy, right? Once I find the apothem. So what I'm going to have to do, though, is draw some stuff. Let's draw the center. Let's put a little dot right there at the center. And tell you what, I'm just going to make this as easy as I can. I'm going to take that to there. I'm going to take this to there. Okay. All right. Well, it's supposed to be right at the dot. You get the idea. It's not perfect, but it's close enough. And since we've been going yellow with the apothem, let's go yellow again. So it's going to be right here. And where is it? It's perpendicular, correct? Yeah. All right. And then it's going to be a right angle right there. That would be the apothem. That yellow one is what we're trying to find. That's what we want to find, is the apothem. Okay? Everybody with me? Okay. Give me just a second. Okay. Now look, what is the 10? The 10 is from here all the way to here. But what do we say about that yellow one? What does it do? It splits it how? It splits it in half, right? So if the whole thing is 10, what's that little bit right there? That's going to be 5. Okay? Oh, you know what? Okay. I was making this a lot harder. They make this a lot easier than I thought. I was just looking at it, and I thought you had to figure out the apothem. They actually tell you what the apothem is. All right? They're not always going to do that. All right? Sometimes you're going to have to figure it out. But this one, shh. Please, Just let me talk. So they actually tell you what the apothem is. They made this like way easier than I thought it was going to be. All right, so I should have looked at my notes, glanced over my notes before I started teaching this. I got them right in front of me, but I'm like, it can't be that easy. Well, it is that easy. Shh. It is that easy. So watch. So now, if I want to find the area, all we had to do was basically just find the perimeter, right? That's all we had to do. That was easy. So the area is 1/2 the apothem. Now they told us the apothem on this problem right here. I didn't realize that at the beginning, but they tell you the apothem. And what's the perimeter? We just found it. It's what? It's 80. So what you're going to do is you're going to put that all into your calculator, and you'll get, let me make sure I use the right one, 484. Okay, that's all calculator work right there. They also tell you this is in centimeters. So what's my area going to be? Centimeters what? Squared. Now, I haven't been taking points off for not putting the units, but some of you guys, it asks for area. I think we had a quiz the last time. It asked for area, and a lot of people are just putting centimeters or just inches. All right, there's no way area is just in inches or it's just in centimeters. It's centimeters squared. Now, I'm not gonna take off on a quiz or a test at this level. I'm not gonna take off if you don't do it right. But I'm telling you, there's teachers out there that absolutely will mark this wrong if you don't put the correct units. All right, so just get used to doing it that way. Okay, get used to putting the right units on here. That's how you do it.
The apothem, 10, like how you said right there.
No, I didn't say the apothem was 10.
Well,
the apothem is 12.1.
Yeah, but like
the side, the length of the side is 10.
10, but you said plus something else, so
Right.
5.
So this would be 5.
So
Right.
why is it 12?
That's not the apothem. They give it to you. They give you the yellow one. They give you this as 12.1. They told you it was 12.1. Okay? The 5 really didn't come into play on this. All right? But sometimes it will. Sometimes they'll do this. Everybody watch? Now, forget these numbers right here, but let's say this. Now, they gave it to you as 12.1, and it's going to be really close. But what if I gave it to you like this? What if I said the radius of that regular polygon, that octagon, was 13? Could you find the apothem?
Yes.
You could find it one super easy way, or you could do a little bit of work to find it. What's a super easy way to find the yellow one? This was on the quiz. Yeah. This basically was on the quiz. It's a right triangle. This is 5. You don't know this one. Well, it's not just a formula. We'll call it A. You could do, what is the formula? Or theorem? What's the theorem? What's the theorem? Give me the name of the theorem. The Pythagorean theorem, okay? You could do Pythagorean theorem to find A. Or you could recognize, we talked about this so much, and yesterday, whatever it was, Friday, we went over the quiz, and I really, really harped on this, okay? I made a big deal about this on Friday, that there's a real easy way to find some of these special type of triangles. We called them a Pythagorean what? Triple. And this is one of them. What is it? 5, 12, 13. Okay? Remember, we had 3, 4, 5. The second easiest one was 5, 12, 13. So you could have, if it was like this, you could have said, oh, that's 5 and that's 13. Well, this must be what? 12. And then you could just put 12 in here and do the work. Okay? So if they give you the length of the side and the radius, you should be able to find the apothem because it makes a right triangle. Of course, you would have to take half of the side, right? Half of 10 to make that a 5. So that would be important to know. All right? Let's do one more and we'll quit. This one is a hexagon. So let's find the area of this regular hexagon, and they're going to give you a, let me change this back to white. They're going to give you the length of the side. All right, but let's draw the hexagon first. Now, if you didn't, let's do this. Let's say you didn't want to sit there and try to draw a hexagon, because that would be a pain, wouldn't it? So what you could do is this. Let's just do, because you don't need the whole entire hexagon, correct? All you need is the length of the side, and what else? The apothem, right? And right, and that. That's really all you need to figure out the answer to this. Okay? Now remember, it's a hexagon. All right, so if it's a hexagon, let's do this. Let's do one more thing. And they tell you the length of the side is 4. So this whole thing from here to here, whoops, is 4. So what does that tell you about this triangle? It tells you this length right here, this little bit right here. What would that little length be? That would be 2. That's right. Now remember, that's the only thing they tell you. They don't tell you the apothem on this one. All right? So that makes it a little tough. But they do say it's a hexagon. So what we can do is see if we can find the angle. All right? And I'll tell you right now, it works out to be something that we just learned how to do. All right? So let's find this angle right here. Well, it's a hexagon, so we can find that whole entire angle. Right? So how do we find that whole angle, that whole central angle? We take 360 divided by hexagons. How many sides? 6. Hex is 6. All right? It's 6. So what is that central angle? It's 60 degrees. That whole angle right there is 60 degrees. So what's this little angle right here?
It's 30 degrees.
Right. So if the whole big, yes. See, now you're seeing it. Okay? So this would be 30 degrees. And this angle right here would be what? 60 degrees. All right? And then that's 90. So now, what do we know? This 2 right here. Let's not put the 2 inside of there. Let's put it out like it normally would go. What is the 2 on this 30, 60, 90 triangle? It's the short leg, okay? So look what we can find. I can find the hypotenuse. That's really easy. What's the hypotenuse going to be? It's going to be 4. And what's the what's this longer leg? Which is our apothem, right? That's our apothem right there. We should be able to figure out what the apothem is. So it's what? Right, it's the short leg times the square root of 3. So it's 2 square root of 3. Do you see where that comes in handy now? Right, so knowing the 30, 60, 90, it's nice because now I can find this. What am I trying to find on this, by the way? I'm trying to find the area, right? Which is 1/2 the apothem times the perimeter. Well, I just found the apothem. It's 2 square root of 3. So I'm going to write 1/2 times 2 square root of 3 times the perimeter. We haven't even talked about the perimeter yet, but the perimeter shouldn't be that tough. How do we find the perimeter of it? What's one of the sides? 4. How many sides do we have? What do we do with those two numbers? Okay, and that's 24. Everybody with me? All right, so let's put it into our formula. There's 1/2. There's the apothem. What's the perimeter of that whole entire hexagon? It's 24. So I put 24 right here. And we could do some work on this. I would do this. Watch. You see the 2 on the bottom? Cancels with the 2 on the top. So really, what is it? It's 24 times the square root of 3. But normally on area, they want it as a decimal. So we'll put approximately. So I'll throw that into my calculator, and it's approximately 41.6. I didn't tell you earlier, but this is in inches. You guys can't just pay attention to the end. You can't. We're just about done. So it's inches squared. And that's how you find the area. Now, why did I make a triangle out? Why didn't I make that big old hexagon? Because I didn't need all of it, right? All I needed was one side. I needed the apothem, and I needed the radius. So that's what I drew. Now, with the knowledge that we have so far, if I had an 8-sided figure, I would not be able to find those angles. I mean, I would be able to find the angles, but that wouldn't mean anything to us. We won't get to it this year. We just barely got into it on the honors class. I skipped ahead to chapter 12, but there's a thing called trig or trigonometry. Have you ever heard that word before? Okay. Sounds scary, but it's not so bad. It is kind of fun, actually. So listen. Shh. I'm not done. I'm not done. So with using some trig, you could take, it doesn't matter how many sides your regular polygon has, you'll be able to find that apothem using trigonometry, all right? But you're kind of limited now. So you have the homework in front of you. I gave you the lesson plans today. So, Trent, what did I give you? 5 to 12? Did I give you 14 to 22 as well? Or is it just 5 to 12? Just 5 to 12? Okay. So it's section 7.5. That's the homework right there.